Okay, now what we are going to do is we are going to learn another type of pattern where we have a repeated set of numbers. Unlike the previous pattern, we had different set of numbers being printed in different lines. Here we have the same numbers being repeatedly printed in different lines. We have noticed this. Here 1, 2, 2, 3, 3, 3, 4 times 4 and 5 times 5. Now for this type of patterns, we cannot use the method which we had learned earlier. Here, if you look from top to bottom, every line have the same set of numbers starting from 1 to 5. You either take this side of the triangle or this side of the triangle. It's always 1 to 5. So that will be your outer look. There is no doubt regarding it. So we can go for this. I have already made a fill in the blanks type of skeleton for this particular type of pattern. So we'll go for 1 till 5 I plus plus. 1 to 5 has to be increased, therefore I plus plus and less than equal to as usual. Now, for the next part, what we are going to do is we are going to determine how many times each of these numbers are getting printed. That is very important. Now, when the value of I is 1, how many times is the number 1 getting printed? Once. So the inner loop should be executed once. So we can tell it should run from 1 to 1. Now next time, when the value of I is 2, the number 2 is getting printed 2 times. So I can tell that it should run from 1 to 2. When the value of I is 3, it's running 3 times. So I can tell it should run from 1 to 3. Similarly, when the value of I is 4, it should run 4 times. So I can tell 1 to 4. When the value of I is 5, it runs 5 times. So I can tell 1 to 5. That is how the entire thing goes. So we can tell if we find out a common relationship between each of the inner loop. These are the inner loops, remember. It always begins from 1. You can notice over here. So we can tell that J begins from 1. Now, when the value of I is 1, it ends at 1. When the value of I is 2, it ends at 2. When the value of I is 3, it ends at 3. When it is 4, it ends at 4. When the value of I is 5, it ends at 5. So whatever is the value of I, it ends at that particular value. So we can tell that it should be ending at I. Very simple. Now, if it goes for the longest line, from 1 to 5, 1, 2, 3, 4, 5. So 5 times 1, 2, 3, 4, 5. Since it is increasing, we are going to put over here J plus plus and this has to be less than equal to. Now, when it comes to printing, there is a slight difference compared to the previous patterns which we had learned. It should be system.out.print, this time I. Now let's see how this entire thing is working. Okay, when the value of I is 1, this loop runs from 1 to 1. 1 to 1, this time you have to think how many times did the inner loop execute. So from 1 to 1, it executed just once. And what am I printing? I am printing I. And since the value of I is 1, 1 is getting printed just once. Now going to the next line, again, next time the value of I is 2. So this loop runs from 1 to I, that means 1 to 2. So how many times this time? Naturally 2 times, 1 to 2. So 2 times I am going to print the value of I. And since the value of I is 2, the number 2 get printed twice. Again going to the next line, the next time the value of I is 3. So this runs from 1 to 3. 1 to 3, again 3 times. And 3 times I am going to print I. So since the value of I is 3, 3 is going to get printed 3 times. Next time I is 4, so it runs from 1 to 4, 4 times. So it's going to print 4 times. Next time value of I is 5, so it runs from 1 to 5. And I'm printing the value of I, so 5 gets printed 5 times. That is how this pattern is created. Now we are going to see one more type of similar pattern. Now I'll try out a similar pattern. See, the pattern is this. Now you can see this particular pattern. Both the sides, apart from the base, runs from 5 to 1. So that will naturally be the outer loop from 5 till 1. And 5 till 1, since it is decreasing, so I minus minus, and this has to be greater than equal to. Now coming further, determining the values for the inner loop. Okay, let's start. When the value of I is 5, how many times is the number 5 getting printed? Yes, 5 times. So we can tell that the inner loop should run from 1 to 5. When the value of I is 4, it runs for 4 times. The number 4 is getting printed 4 times. So I can tell it runs from 1 to 4. When the value of I is 3 times, so 1 to 3. When I is 2 times, so I can tell 1 to 2. So when the value of I is 1, it executes once, so 1 to 1. From here we can determine the inner loop always begins from 1 as usual, just like the previous pattern. So we can start from 1. And where does it end? When the value of I is 5, it ends at 5, 4, so it ends at 4, 3, it ends at 3. When the value of I is 2, it ends at 2. When the value of I is 1, it ends at 1. So I can tell it ends at I. Now looking at the longest line, that is the base. This is the base running from 1 to 5. So 1 to 5 it is increasing. So therefore I can tell this is plus and this has to be less than equal to. As usual, you have to print I. Because when the value of I is 5, it runs from 1 to 5. And you need to print I, that is 5 times. Note the difference. When the numbers in a row are changing, we need to print J. When it is repeated numbers, we need to print I. Now we are going to try out one more similar type of program. Now look at this pattern, though it looks same like the previous two patterns, there is a subtle difference between those two patterns which had repeated numbers. This is quite tricky. You are going to find it out how or why. Looking at both the sides, leaving the base, there are two sides and both the sides the number are changing from 5 to 1. So that will be our outer loop. So that's pretty simple. I is 5 and ending at 1. So 5 to 1 it is decreasing. So therefore I minus minus. Now determining the inner loop is quite tricky. We are going to find it out. Okay. When the value of I is 5, instead of printing 5 times as in the previous case, it should print just once. So can I tell the inner loop should run from 5 to 5 times. Okay, this is quite tricky. 5 to 5 times. Why am I starting with 5? Because it's easier for me to represent that using I. So 5 to 5. When the value of I is 4, it should run from 4 to 5. Now look at this, how this is working. When the value of I is 5, it runs from 5 to 5. 5 to 5, how many times did it execute? Just once. And 5 needs to be printed just once. When the value of I is 4, this loop runs from 4 to 5. So 4 to 5 indicates 4 and 5. That is 2 times the loop executes. And I need to print 4 2 times. When the value of I is 3, I can tell it runs from 3 to 5. So 3 to 5, 3 times, 3, 4 and 5. So 3 times. When the value of I is 2, 2 to 5. So 2, 3, 4, 5, 4 times. 4 times 2 is getting printed. When the value of I is 1, 1 to 5. 5 times the number 1 is getting printed 5 times. So we can tell from here easily that whatever is the value of I, the inner loop starts from there. However, it always ends at 5. Look at that. When I is 4, it starts from 4, ends at 5. When I is 3, it starts from 3 and ends at 5. When I is 2, it starts from 2 and ends at 5. So we can tell it starts from I, whatever is the value of I, it starts from there and ends at 5. Now determining whether plus plus or minus minus, look at the longest line, this, that is the last one, 1 to 5. So 1, 2, 3, 4, 5. So naturally this has to be increased. See how simple it is. Now we are going to try one more similar pattern like this one, which is quite tricky. You found it out. Okay. Now you can see this pattern. 1 is getting printed 5 times, 2 4 times, 3 thrice, 4 twice and 5 just once. Even finding out the inner loop out here is quite tricky. Anyway, the outer loop we can easily find out. That is from 1 to 5. Either way, it is 1 to 5. So 1 till 5, I plus plus. So now determining the inner loop. Okay, when the value of I is 1, this 1 gets printed 5 times. So I can tell the inner loop should run from 1 to 5. Easy to determine. I is 1, so I am going to begin from 1. When I is 2, 4 times, so I can tell it can run from 2 to 5 times. 2 to 5 times, why did I select this? 2, 3, 4, 5. So it's 4, so therefore 2 gets printed 4 times. Next time, when the value of I is 3, it runs from 3 to 5. 3 to 5 means thrice, 3, 4 and 5. This is what happens. When the value of I is 4, 4 to 5. 4 to 5 means 4 and 5, 2 times. So 2 times 4 gets printed. When the value of I is 5, 5 to 5. Just once. So we can tell that the inner loop starts from I but always ends at 5. Now determining the plus plus minus minus, if you look at the first line, which is the base, the inner loop runs from 1 to 5. So 1, 2, 3, 4, 5, it's increasing, so therefore plus plus. And if it is plus plus, this is less than equal. Now see how this is working. When the value of I is 1, it starts from 1 till 5. And what am I printing? I. And since the value of I is 1, 5 times 1 gets printed. When I is 2, 2 to 5, 4 times, and 4 times 2 gets printed. When I is 3, 3 to 5, 3 times, so 3 gets printed thrice. When I is 4, 4 to 5 twice, so the number 4 gets printed twice. When the value of I is 5, 5 to 5 just once, so 5 gets printed once. Okay. Now we are going to learn about another type of pattern called the grid patterns. Now, when it comes to grid patterns, now you can see it's peculiar. You have a lot of spaces, unlike the previous patterns. Moreover, we have an asterisk out there. It may be numbers also. Basically, the logic is almost same with numbers, even if it is of this shape. But one primary difference between the previous patterns which you have learned and this pattern is, those patterns were triangular patterns in nature and was always aligned to the left. So the triangles were always right angle triangle towards the left hand side. Here, what we have is, we do not have such a thing. Both the sides are aligned almost in the same way. And here, the first pattern is a cross. Now, when it comes to this pattern, we are going to use grids. Now, what do I mean by that? I'm going to show you. I'm going to make horizontal and vertical lines to form grids. So, this is the first row, this is the second row, this is the third row, this is the fourth row, and this is the fifth row. So again vertically, so we have the cells inside which the asterisk is printed. Now we are going to name this as 1, 2, the second row, third row, fourth row and fifth row. So these are rows. Now these rows are the outer loop. Let's name it as I. So here the first loop will range from 1 till 5 I plus plus. Now, this column numbers are the J loop, that is the inner loop, starting from 1 to 5. So, here we have from 1 till 5 J plus plus. Now, these numbers can be any sequence. You can take from 1 to 5 or 5 to 1. Similarly, for the columns also, you can do similar things. But it depends upon what the conditions will be. Now, what do I mean by all that? Let's see. We are going to write the position represented by its row and column position of every cell in this grid. So here, this particular cell is in the first row, first column. First row, second column. This is first row, third column. First row, fourth column. That is how we write. This is the fourth row, second column, 4, 3, 4, 4, 4, 5, 5, 1, 5, 2, 5, 3, 5, 4 and 5, 5. Now, if you look at this carefully, you will find, look at the cell or coordinates of the asterisk. in this left diagonal, and on the right hand diagonal, look at it carefully. Each of this coordinates, that is the row and column position of every cell, is actually I and j, I comma j. So each one of them are I and j, you can imagine. So here, in the first case, that is the left diagonal or major diagonal, whatever you may call it. If you look at the relationship between I and j, you will find that the value of I and j is always same. Look at this. I and j is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So the value of I and j is always same. So we can tell if the value of I and j is same, I am going to print an asterisk. Otherwise, I am going to print a blank space for the remaining spaces where asterisk is not printed. And after the line has ended, we'll go for the next line. That is the usual technique which we had learned with the prior patterns which we had learned. Now notice carefully the right diagonal. In the right diagonal, what do you find? In the right diagonal, if you look at it, look at the first cell out here, 1, 5. This is 2, 4. This is 3, 3. This is 4, 2. This is 5, 1. If you notice carefully, the sum of all these coordinates happens to be 6. See, 1 plus 5, 6, 2, 4, 6, 3, 3, 6, 4, 2, 6, 5, 1, 6. So we can tell when the value of I is j or I plus j is 6, then I am going to print an asterisk. Otherwise, I am going to print a blank space. Now friends, please remember that this is the trick of this grid patterns, where we need to find out a relationship between I and j. Sometimes the condition may be, you might find always the value of I is constant or the value of j is constant, so that may be a condition. Sometimes the summation may be equal, like we found it in the right diagonal case, or sometimes even the difference may be constant. So some kind of relationship you will always get with this grid kind of patterns, when it is not aligned in any direction as such. So now we are going to try out a similar pattern. Now look at this pattern. We have almost in the shape of a pyramid. You can see the asterisk, and unlike in the previous case, drawing the entire grid, what I did was I just wrote the coordinates of each of this asterisk. That is the position. Same way, I have divided this into 5 rows. And there are 9 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 columns. So, rows are always the outer loop. That is, it will run from 1 to 5. And the columns from 1 to 9. Now, let us look at the condition. Now, look at this particular diagonal shape, this particular side of the pyramid. You will find each one of them, remember, it is I and j, and the summation is always 6, if you notice carefully. So we can tell if the value of I and j is 6, or now for the next one. If you look at this, here the difference between them, that is if you do j minus I, that is the second coordinate minus the first coordinate. So j minus I is always 4. Look at it carefully. 5 minus 1 is 4, 6 minus 2 is 4, 7 minus 3, 4, 8 minus 4, 4, 9 minus 5 is also 4. So we can tell if j minus I equal to 4. It's that simple. Grid patterns are pretty simple. Okay, now we can try out one more problem related to this. Now look at this particular pattern. It's a cross and of course created using the asterisk. Now, it is divided into 5 rows and 5 columns. So, let me write only the condition for the asterisk. This is first row, third column. This is second row, third column. Third row, third column. Fourth row, third column. Fifth row, third column. And this one is third row, first column. Third row, second column. This is third row, fourth column. And third row, fifth column. Each of the coordinates are I and j, I believe you remember. So the rows are ranging from 1 to 5. So this as usual from 1 to 5. And the columns also ranging from 1 to 5. Very simple. Now coming for the condition. Now if you look at this particular line, here look at the value of I. Remember I comma j, each of these coordinates. Look at the value of I. It's always 3. Had this been the row, the value of I would have been 2 because every ith location of the coordinate is 2 and here it would have been 1. Out here, this is quite unique. The value of I is always 3. So that will be the first condition. If the value of I is 3. So we can also have a constant as a condition. And if you look at this, the value of j is always 3. Fixed. That is constant. So we can put or j is 3. That's it. It's that simple.